Section 4.8, we're going to be focusing in on a few applications, and there are many applications, but we're going to focus in on a few of them for these trig functions. Okay. Now, the first one that we're going to do, it really has to do with navigation. Okay. And in order to talk about this, we need to understand bearing. Okay. And bearing is really just how we're going to describe direction. Okay. And let's just read the definition and then we'll see how it applies in these two examples here. But it says the bearing from point O to point P is the acute angle, so we'll always be giving an acute angle, measured in degrees between the ray OP and the north-south line. Okay. That is the part that confuses people the most, as they forget about this north-south line part. And in this situation, why don't we actually, in both of these pictures maybe, sketch in the north-south line, right? It's this thing. I've done a bad job of outlining it. Okay, that's our north-south line. Okay. And if we're trying to give the bearing for this angle that's been sketched here, we actually want this angle in here, that angle theta. We don't actually want this angle 68 degrees here because it's not off of the north-south line. Okay. So if we're trying to find that angle theta there, we have theta is equal to, and remember, it would be 90 degrees if we did that full rotation from the east line to the north line here. So I'm going to write 90 minus, and so if I take away that 68 degrees, that should leave me with the angle theta. Okay. And so that should be 22 degrees. Now let's look at the one in part B here. Okay. It's already off of the north-south line, so we're not going to have to do what we just did. Okay. It's already there. But there's a little bit more to this than just finding that angle. So we want to actually write this as well. So this first one, you can see it's pointed northeast. So if you want, you could actually write in north. You could write in east. And all you're missing is the angle. So the 22 degrees. And the way this reads is north 22 degrees east. And is what it means is that the direction that we're headed is measured 22 degrees off of that north line towards the east. Okay. And let's try this one over here. You can see that this angle is pointed southwest, so you could write in SW. Okay. And we'll always write in north or south first, and then east or west second. But again, we want the angle that's measured off of that north-south line. Okay? And if we're measuring off of that, we have 70 degrees there. So south 70 degrees west, okay, which means that the direction we're headed is 70 degrees off of the south line towards the west. And let's try an example. Okay. So, see what we have. A ship is 9 miles east and 6 miles south of a harbor. What bearing should be taken to sail directly to the harbor? Okay. Let's draw a picture. That's actually going to be really helpful on all of these navigation questions where we're talking about bearing. Okay. So let's maybe call this the harbor right here. And remember, the ship here is 9 miles east and 6 miles south of the harbor. So I'm going to head south here a little ways. Okay, so that's towards the south. And then I'm going to go to the east. Okay. And you should be thinking about like a compass here or a map. Let me try and draw those axes a little straighter there. Right? North, south, west, and east. Okay. And so I'm going to also sketch in our ship here in a second. Let's say that it's right here. Okay. And so we know, again, 6 miles south, so the length of this is 6 miles, and 9 miles east of that harbor. Okay. And now, again, we're asked to find the bearing. Okay. We want to find the bearing. So I'm going to sketch in something else here. All right, and so you might be wondering what I am sketching in. And is what I'm doing is I'm actually sketching in the north line there. Okay, that's going to be helpful because I want the bearing that this ship has to take to go towards the harbor. Okay, right? I need some way where I can describe this direction towards the harbor. Okay. And if we're using bearing, right, it has to be off that north-south line. So is what we want to find here is actually this angle. Okay. That's what we want to find. Okay, well, how do we find that? How do we find that angle? Well, maybe we can find this angle in here. Okay. Let's maybe call this one theta prime, just to note it's a different angle. Okay. So if I wanted to find theta prime here, what could we do? Well, we could use SOHCAHTOA, right? And I think TOA would be the better option here. So we have tangent of theta prime is equal to opposite over adjacent. So 6 over 9, or how about 2 over 3? And so if I want to figure out what theta is, well, we can take tangent inverse of both sides. So we get theta prime is equal to tangent inverse of 2/3. All right, and if you were curious what this angle came out to be, you could plug it in your calculator, but I actually don't need to know exactly what this angle is because it's not the angle I'm looking for. Okay, this will suffice, okay, for theta prime. Okay. Well, let's go and figure out what theta is. Well, theta, well, you can see that should be 90 minus theta prime. Or how about 90 minus tangent inverse of 2/3? And now this maybe you want to plug in your calculator. Okay. And if you do, you'll get approximately, if you round to the first decimal place, you'll get approximately 56.3 degrees. Now that's the angle theta we wanted. Okay. Maybe I'll sketch this in here in blue. Theta. Okay. Now, the last thing we have to do here is actually write this as a bearing. Okay. So you can see that we would need to head north and west. So north and west. And the question is, how many degrees from the north towards the west are we going to go? And we found that to be about 56.3. bring my N and W a little bit closer here. And there's our answer. All right, we have another one here, and I want you to pause the video and give it a try. And what we'll do is actually in the beginning of the next video, we'll start this problem.